In this video, we'll talk about classifying triangles. Recall that a triangle is a three-sided polygon. Triangle ABC, written as, and we use the triangle symbol, ABC, has parts that are named using A, B, and C. The sides of ABC are AB, this line, BC, this line, and CA, this line segment. The vertices are points A, B, and C. So the endpoints here, A, B, and C, and our angles are formed, so BAC is formed, you can kind of draw from one point to the other. When we go from BA to C, we form BAC. When we go from A to B to C, ABC, this angle is this one. And when we go from BCA, B to C to A, it forms this angle here. Triangles can also be classified in two ways, their angles or by their sides. All triangles have at least two acute angles, but the third angle is used to classify the triangle. So in this picture, we have first an acute triangle, which is three acute angles. An acute triangle is also can also be an equiangular triangle if all three of the angles are congruent. So this notation here shows that all three are congruent. So three congruent acute angles is an equiangular triangle. We would just call it an acute triangle if it has all degrees less than 90 for each of its angles, and they're not all congruent. An obtuse triangle has one obtuse angle. So one angle, this one here, that's greater than 90 degrees. Whereas a right triangle has one angle that is equal to 90 degrees, or a right angle. In classifying triangles, we want to be specific as possible. While a triangle with three congruent angles is an acute triangle, it is more specific to classify it as an equiangular triangle. Let's look at a couple examples. Use the best description to classify each triangle. In this example, we have three angles, 1, 2, 3, that are all less than 90 degrees, but they are not equal to each other. Since they're not equal, but they're less than 90 degrees, it's going to be an acute triangle. The next one does have an angle equal to 90 degrees. Whenever we have an angle equal to 90 degrees on the triangle, it's going to be called a right triangle. In this example, it asks us to classify PQR as acute, equiangular, obtuse, or right. So to classify this triangle, we have to look at our big angle here, which is actually the addition of 45 plus 59 to get this angle. So angle PQR equals 45 plus 59, which gives us 104. And that's greater, 104 is greater than 90 degrees, so we're going to call this one an obtuse triangle. Triangles can also be classified according to the number of congruent sides they have. To indicate that sides of a triangle are congruent or equal, an equal number of hash marks is drawn on the corresponding sides. So an equilateral triangle will have all three congruent sides, whereas an isosceles triangle is going to just have two congruent or equal sides. Lastly, the scalene triangle has no congruent sides, so you'll see no hash marks on the scalene triangle. Let's look at a few more examples. Classify the sound box of the Russian lute below as equilateral, isosceles, or scalene. So this triangle has two equal sides at 16, but one that is not equal. So since it has two equal sides, it's going to be isosceles triangle. for this example, it says if point M is the midpoint of JL, classify JKM as an equilateral isosceles or scalene triangle. So first it says M is the midpoint of JL. So M is the midpoint of this line. So that means that JM is going to be equal to LM. So let's put a hash mark to show that these two are equal. So if JM is equal to LM and they both add to 1.5, we can say JM plus LM equals 1.5. And we already said JM equals LM. We can use substitution and say 2JM equals 1.5. Then divide by 2, division property of equality, we get JM equals 0.75. So this part equals 0.75, and we can see from the figure that this side equals this side, and this side equals this side. So by the transitive property, we can say that this side here also equals 0.75, this side here. So since they're all equal to each other, it is an equilateral triangle. In this example, we need to find the measures of the sides of the isosceles triangle ABC. So it tells us to find x. So since it's an isosceles triangle, two of the sides are going to be equal to each other. So it tells us with the hash marks, this side is equal to this side. So let's set those variables equal to each other. 4x plus 1 equals 5x minus 0.5. So let's subtract 4x from both sides. We'll add 0.5 to both sides. So we get 1.5 equals x. So x equals 1.5. Then we can plug our x back in to each equation to get the length of each side. So 4 times 1.5 plus 1. That becomes 4 times 1.5 is 6 plus 1 equals 7. In our other equation, 5 times 1.5 minus 0.5. And we should get 7 when we add this together because we know that they're already equal. So 5 times 1.5, that gives us 7.5 minus 0.5, and that does give us 7. So that adds up. We can check our work. These are equal as we expected, and it's an isosceles triangle. So we can confirm that x is equal to 1.5.